Thanks very much for that lovely introduction. I covered a few of the things I was going to start with. But it's certainly a pleasure. It's great to see so many people here. That's something I've noticed in Australia on this trip. Australia's passion for space and interest in space and space technology is fantastic. It's something that you don't see in every country, really to the level that you see it in Australia. It's great to see Australia getting behind the new space agency, which started just last year. And it will be an exciting time for Australia in space. Close up? Okay. All right. Okay. I'll try to use the microphone to get my voice to go further. All right. So it's been a lovely trip for me out in Australia this time over the last 2 months. But when I'm back at home in Germany, in Bremen, I work at OHB, and I tend to go by the term of space flight hardware specialist. It's a long, complicated term, and it doesn't mean very much unless you're deep in the business. It covers really how we take technologies that we use on Earth and those that we currently use in space, and how we can apply them to space missions. So in the case of the Mars probe, what sort of materials we could make that out of, what sort of technologies we have here on Earth that we could utilize to build a probe that works on Mars as well, which is not as easy as it sounds, even if it sounds hard. So what I work on now is application of technologies for future missions in science, exploration, and this technology development, which is taking some of those technologies from Earth and looking to use them in space. And I'm working on a couple of pretty exciting projects at the moment. One which is a joint mission between NASA and the European Space Agency to fly a spacecraft to an asteroid. NASA's spacecraft will fly there, smack into the asteroid and move it, and they'll watch that all from Earth. But what we also really want to know from the European perspective and from a global perspective is what can we do about these asteroids in the future? And that's what this mission will do from Europe, is let us know better what we can do about those asteroids that might threaten us. Because at the end of the day, we don't want to be dinosaurs. We don't see them walking down the street anymore. And so also we work on things like making space safer for the future, which is really important in terms of where we can go for future spacecraft. And also that when the spacecraft come back down, they're not going to come down and hit someone. And that's something I also enjoy spending a lot of my time on. So I'd say it's got a noble goal, certainly, and we get to do a lot of physical testing and building of future joining technologies, where we go and we replicate the situation, how it would come back down and how it would burn up. And that's what I spend most of my time on these days. And I wanted to follow a bit of the path that I took coming from Melbourne, growing up here in Melbourne, and getting to building a probe for Mars, and being involved in a mission like that. And to give it context, what I wanted to do was go for a little hysteron-proteron, so go from the end at the start, and then follow that track that I took to get there. So for those who don't know, I guess you picked up on the whole path that I worked for some years very intensively on a probe that's now sitting on Mars. So right now, very excitingly, it's sitting there on the lander of the spacecraft which NASA built. And it's waiting for the robot arm to put it on the surface so that it can make its first digging actions. I'd certainly hoped that we were actually digging already by this stage, but what's happened is, as with any project, there have been a few delays, but luckily so far none too major, nothing that's risked the mission, and so we're just waiting for that part. The mission itself is a mission from NASA, and it's called InSight. It focuses on looking inside Mars, hence the name InSight. And it's something we haven't done much of on other missions. So as people would know, there's been a lot of missions to Mars, especially quite the famous rovers, but a number of landers as well. And we fit into that lander category. We don't want to anymore. We have done it. We've landed on Mars now, which is fantastic. Those last 6 minutes of landing are hair-raising. You wait, you have no information, and then you get more or less a couple of flashing lights back. And this time we got those flashing lights back, which was fantastic. So we were very happy about that. So it's sitting there on Mars now, and the primary experiment is a seismometer, what is a relatively common piece of equipment here on Earth, but is much, much harder to use in the application to go and place it on Mars. It has to deal with being outside, with dust storms, with influences from the day-night cycle, and they've just closed the last part of that to place a protective shield over the top. So now we'll start to look for Mars quakes and seismic activity on Mars to know more about what Mars is like today. And we can look at Mars quite easily from Earth, but to understand the surface, and especially to understand what's happening inside, is very difficult without a craft there on the surface. As a secondary experiment, or so not the primary experiment, but another one, to look inside at what Mars is doing right now, is what we call the HP cubed experiment. But for ease, I'm mostly going to call it the mole and the mole house. So we built in Bremen at the German Aerospace Center Institute of Space Systems. We built the mole, and we built the mole house, and there's a number of supporting items that makes up the full HP cubed experiment. And the mole looks very simple. Oh, I forgot my prop. Oh, I'm passing that. Oh, that's right. So the mole, the intention of the mole is to dig down to 3 to 5 meters to very, very sensitively measure the temperature of Mars' core and the surrounding sand, telling us not only about Mars itself, so the local vicinity of our spacecraft, but also that the current state of Mars, what Mars is doing, and what we can use that information with together with the seismometer is to better understand how Mars was formed. And that's something we really want to know about in terms of our broader solar system and understanding how our solar system works. Now the mole has to dig down to 3 to 5 meters, which sounds very easy here on Earth. If you have a digging machine, or even if you have someone with a spade, you give them enough time, they can dig down. But Mars is far away, and to think of just the lander craft, the dinner tables here today are considerably larger than our craft itself. So that starts to give you an idea of how big the experiments must be. They must be small enough to fit on top of that table. And our entire experiment, so the mole house itself, looks about yay big, and inside that sits the digging mechanism, which is conveniently about the size of a rolled up serviette. So we have this little mole, just this long. It's a self-hammering penetrator. It's the type of digger that we use. And inside it has a hammer which is hitting away every few seconds, so it's much quicker than it actually goes. Pushing itself down at the beginning, we're talking about a millimeter range. On a good day, we might get 3 to 5 millimeters out of a stroke. But as we go deeper and deeper, we're talking about each stroke every time, just digging 1/10 of a millimeter or so. And so it's not going to go down quickly, but we're pretty sure that it's going to go down. The mole we had to, because we're sending it so far and it has to be reliable, we had to keep it relatively simple. I say relatively simple, it's certainly a complicated experiment for the size that it is. It doesn't react to its environment, we can't control where it is going, but there are a number of features to make sure that it goes where we want it to go. As it works its way down, it can work itself around rocks, it can work its way through difficult sand, and if it gets really stuck on a rock, it has the feature or the capacity to slowly smash its way through rocks. That's going to go even slower then, but it can get through. The mole is very robust. It has to be to do a job like this. It's more or less hammering itself to pieces over time. And so that was something that was very tough within the job I did. So my role and my personal perspective and how I got there, I was very involved in practical and technical projects, building of experiments, and initially within the HP cubed experiment, or just stick to the mole and the mole house, I was responsible for all the development testing we had. So we started with a concept where we built models, therefore, to test that, to see what we could do on Mars. And I was responsible for building test facilities, building the models themselves, and testing them, which was a pretty full-on job with a very small team, but a very dedicated team. These things don't happen on our own, but we're always working in teams. And as things get bigger and bigger, those teams have become more and more enormous. I was also lucky to have the benefit to go up to be responsible for the mole and the mole house later on, when it came time to build the flight hardware itself. Because even within the space community, there are not so many people who work with that space flight hardware. And that was one of the strong things in my experience, in my skills, that gave me those roles within the project. And those things all together, in the end, we call them assembly, integration, and test, and assembly, integration, and verification in the space community. And that's really putting it together, making sure it works, and sending it on its way. So after we sent it on its way, that's when I moved over to my future mission work, because that was done. And there were a few skills, so looking at that role within Insight, especially, I wanted to describe the path towards. Really, they came down to, I had here 3 more or less, which is coordination, which was really key. Most of the job is getting things sorted out, getting things fixed, and solving the small problems that come along the way. The technical background was very important, but even more important than my technical skills and know-how was, in the end, my practical skills and know-how. That became very important, especially within small teams, being flexible, being to take on new tasks, and take on new roles as happened within there. And one which was key from my studies and experiences in Australia was having a good basis in science and engineering practices and taking those along the way. And that's something which we refer to sometimes as part of the Aussie advantage. Over in Europe and in the US, within the space community, Australians are known for those skills, both their science and their engineering practices and their commitment to them as well. So, going back to the other start, so to say, was mentioned about my beginnings for my passion for space. And I don't remember a time where I wasn't passionate about space. Growing up as a kid, I would read space books, I watched Halley's Comet as a young child. Yeah, those books are still all there in my parents' house. They've kept them all. I'm always bringing them out when people come around to visit. But I didn't just have a passion for space, I really had a passion for engineering. And as a child, then also growing up, I didn't really understand it as engineering. But I would do things like pull all my toys apart. And I still remember the one toy I couldn't get to go back properly. It had one spring left over, and for the life of me, I couldn't remember where it had come from. But these things, they helped actually. These practical skills, ironically, I still use in my job today. Now when I pull things apart, I'm very careful to take photos if people stand away. Having that passion and very strong desire to work within the space community, I looked at what I could do. I was relatively sure I wanted to go forward with engineering in some aspect or an application of engineering, but I wasn't sure how. And in my last years of high school at Camberwell Grammar, I realised that where I wanted to apply myself was space. I looked at the different frontiers. I liked the very small, I liked the very big, and spacecraft themselves is a combination of both. They have to be small, light, and they have to go out into the vast unknown, which is exciting as an engineer. It's also sometimes a little hair-raising, certainly makes you nervous when you send things out. It's been a big year this last year. I've had a lot of hardware go up into space, and every time you're just as nervous as the last time about whether it's going to work or not. So I'm going to keep my fingers crossed for them all in the next weeks. So in order to do that, I took one of my first critical choices, which was to do a double degree in astrophysics and mechanical engineering, which at the time and even now is a pretty uncommon combination, science and engineering being common, but the astrophysics and mechanical being a little bit less so. And at the time I wanted to do astrophysics and aerospace, but due to the university system I couldn't. But it became one of those choices, looking back at lessons learned, that was really in my favour. As a mechanical engineer in an industry dominated by aerospace engineers, I have an edge. I have skills and I have a technical background that other people do not. And I took that into my career, into those practical skills in terms of sometimes things as simple as understanding how bolts work, a little better than everyone else. But everywhere you go, you'll see a bolt. From there, knowing other Australian expats within the space community, there was really 4 paths open to myself. There was the one which I thought was the best choice for me, which was to go out and get some experience within Australia and then take that experience over to Europe. I always had Europe in my mind when I was thinking about space rather than the US, but one of the two would have been my options. And then make something like a field change, so build up some skills that I could take from Australia and take them overseas, looking especially at transferable skills from fields such as power generation, try to think of some more things like the aerospace industry. Those all go pretty directly across into the space industry with a little bit of training. But in this case, I was quite lucky to meet, it was the course coordinator of a course over in Europe. He was out in Australia for a visit. And my university at the time, at Monash, they encouraged me to go and speak to him because of my interest in space. And I met with him, and he was very passionate about getting me to go, which was good. That gave me the kick, the push, to apply for the course that he was running. This was led by Lulea University with a consortium of 5 other universities. So it was a very scary move, but it was another one of those critical choices. It was a tough choice to leave Australia. I still love Australia, having grown up here. I always loved coming back, and leaving was very tough. To leave my family, my friends, my culture as well, and to go out into, for what was me, the unknown, into Europe. This ended up working very well for me. I also wanted to mention on the other 2 paths, because they're just as important, and they're paths that other people take, in terms of becoming very specialised within Australia, taking a doctorate, going overseas and doing so, following a path into the space community that way. And now, I wanted to mention this one because it's so fantastic. Now, people have opportunities here in Australia, and that just wasn't really the case 15 or 10 years ago. There were just very few opportunities for engineers, for scientists, a little more for scientists. Not many opportunities to follow a career in space in Australia. It's fantastic that that is changing now, and that is in large part because of the passion that Australians have for space. The master's course was fantastic. That was one of these critical choices I made along my path towards building the instrument. What I hadn't expected out of it was the networking potential. I hadn't, as an undergraduate, understood how valuable that was in terms of getting where I wanted to be. And the master's course started to give me that. I worked on things like student projects as much as I could while I was there, because I quickly realized that brought me into contact with industry and skills that I could take straight into industry. So building on those practical skills which I had from my childhood from Australia, and building them and learning more about the space industry and community. Along with the student projects, I also pursued as many internships as I could while I was there, for the same reasons, bringing me into contact with more of the industry and the community. But as I more or less covered, that was a really tough decision to follow, and understanding concessions to do that makes it more clear why we do see a lot of Australians over there. There are a lot of very committed Australians in Europe and the US building hardware to go to space. During the master's course, I started to understand this Aussie advantage, which was particularly good. We're known for being hardworking, committed, reliable, honest. We have a great reputation in Europe. It commonly comes up, people are surprised to see us there, but there are a lot of us, especially within the space community. And all those people there continuing to work hard and make these efforts keeps that reputation going. And it certainly makes it much easier for us as Australians to find work within Europe, which is great for the next generation as well. So I tried to think about lessons learned that I had. Australians, in terms of that character and reputation as well, we come with an advantage of being friendly, or that expectation that we're friendly. I mentioned dependability and honesty, but that friendliness is really, really important, and something I think I didn't realize when I went over. But being nice to people and not being a jerk to people is one of the most important things. And that's suited me very well in my career. So I wanted to cover a bit of my professional career, which took me to that last part before leading into questions. I hope I'm okay in time so far. So what was within my career itself over the last 10 years, I took those experiences from my student projects and internships and went into positions where I could use those skills. So my hands-on skills, but also my technical knowledge, and my knowledge of how to apply technology for space missions. I also very quickly fell into or came into leadership roles within my projects. It's not always something that I pursued personally, but perhaps I hated seeing things done not the way that I wanted them to be done, which helped to give me a bit of a push to do that and to follow that path. But both have been very important. One, without the other, doesn't make a career, at least within the space community. Leadership skills without technical know-how means a lack of understanding for how to build a spacecraft, or what I do now, and what I did before as well. And that was very lucky, especially starting at the German Aerospace Center at a primarily research organization, about having the option to do a lot of this and needing to be able to do a lot. We tended to work in quite small teams, building up to larger teams later on, but you always needed a lot of skills to get through, and to get through on your own, personally and as a team. And that technical experience, built on my education in Australia, and then the further education in Europe, and my projects, is what led me into the role I got within the Mars group, within HPQ. And so, yeah, it wasn't something that happened overnight. It wasn't an easy path, but it was something that happened slowly, step by step, that I built upon. And I think this was the biggest lesson learned for me about my career path up until then, I would say, not including the last part. But one of the most important was to leverage my own personal skills and the experience I was building, and to look at the experience that I needed to work on the things I wanted to do. More or less, yeah, okay, I had a couple more notes here. It's something that I found, so I've spoken with a couple of other groups while I've been out. One of the questions that I've got a lot is, what was it actually like working and building an experiment to fly to Mars? And the very short answer is tough, and the long answer is very tough. We still meet up, myself and the team that I worked with, and we look back on those days already a little with rose-tinted glasses. We said, oh, weren't they lovely times? And then we remember the weeks that we were working 7 days a week, 12 hours a day or so, sometimes not on the books as well, where we take things home, because we knew we needed to get them done, to get those things ready to follow the rules that NASA was imposing on us, to get our experiment to fly. So working with NASA is very tough, and building things for space is very tough. But there is a bit of fun along the way as well. Yeah, so nowadays I've gone over the future missions. It's actually largely for a reason that was mentioned earlier. I have 2 kids now. 7 days a week, 12 hours a day is a bit less preferable when you've got 2 kids at home. Future missions is a little bit more reliable in terms of where I have to be and what I have to do there. But it's certainly fascinating, and it's really fun to work on the asteroid mission and making satellites safer for people these days. So there's many paths that can take you to missions like these, and people need to find their own paths, and people do that. And it's great that there has been that additional path now, that people can follow their passion for space and their career for space in Australia in a good way. For me, there were 2 main things that worked for me and brought me there. It was transferable skills, leveraging my experience, and perhaps most important of all was the one which got a bit of a laugh before, but when you go to work, just don't be a jerk. Thanks very much.